Okay, welcome to week 8. This is an exciting week. I've been waiting for this week all semester. I get really excited about this stuff. I'll try to speak slowly so that I don't talk faster than you can understand. I wanted to take a step back and illustrate a point that I've made in passing a little bit throughout the semester, and that is how memory relates to what we use in our program. So we've talked about how when we create a new instance of a class, that this thing that's called an object, the memory for it is allocated in another part of memory. And the same goes for arrays. Arrays are special types of objects. But when we say new, we're actually allocating memory somewhere else, and then what gets assigned to our variable is actually a pointer to that memory. And then we can pass that pointer around. That's what pass by reference means. But the point that I'm trying to make, pardon that pun, is that everything in a computer boils down to being a 1 or a 0. So our memory, whether it's in a file or whether it's in the RAM of our computer, is nothing more than a sequence of 1s and 0s. And we organize these into bytes because that works out really well with the circuitry. And then we come up with ways of showing what's in those bytes in fewer, like a byte is 8 bits, right? But reading 1s and 0s gets hard pretty quickly. So we invented notations like hexadecimal and octal and decimal to represent what we're already more familiar with. We're familiar with decimal or base 10 numbers, where every digit is a power of 10. And in binary, every digit is a power of 2. And in hexadecimal, every digit is a power of 16. So it works out nicely that way. What we're seeing on the screen here is the contents of a file that I created. And you can see this is in Visual Studio Code. This is actually a extension that I installed in VS Code called the hex dump. And what it does is it will allow you to view binary data in files in hexadecimal format instead of its raw 1s and 0s. So the blue labels are just labels that help me figure out where I am in the file. There's an offset going across the top, so it presents 16 bytes across the top, and then it just counts the number of rows that we have going down this way. And the white stuff is the data, the values in my file. So you can see over here, the text encoding of this data this is raw data, and then there's some dots after that, and we can look over here and see the corresponding. So if I click on this 3, then it'll highlight that dot over here, and I click on that 20, that highlights that dot there. That dot, the 20 is hexadecimal 20 is our decimal number 32, which by experience I happen to know is a space character. So but there's nothing that makes that a space character except for the way I tell the computer to interpret it. And that's what I wanted to illustrate right now is we are simply telling the computer, when we indicate what type of data, an int, a float, a double, a string, an array, whatever we're telling our computer that the data type is, we're actually just telling the computer how we want it to interpret those 1s and 0s at that spot in memory. So if I hover over this 54, and that's 54 hex, then this little tool in VS Code will actually interpret that byte of data or the data that starts at that point in lots of different ways. So let's just take a quick look at this. So we're at address 0, that's the first byte of the file, and of course in programming everything starts with 0, right? So we're at the first byte of our file. If we interpret it as a single byte of data, it holds the number 84, and that's 84 in our terms, in decimal terms. So 84 in decimal terms is represented as 54 if you were to convert that to hexadecimal form. If it's an unsigned integer, that means it can only have positive values, so we get 1 extra bit to represent data values, then it's still 84 because that's just the way numbers work. We haven't overflowed anything. A signed value can go, a signed byte in Java, by the way, can go from -128 up to positive 127. And Java doesn't have unsigned data, but this is a tool that's not specific to Java. So if we were programming in C, for example, we could say, I want to use all the data, and so I can start counting at 0, and I can go up from 0 to 255. That's just a little aside from here. But what we're saying is if I interpret the 1 byte starting at location 0 or address 0, it holds the number 84. If I interpret the data starting at address 0 as a 16-bit integer, so that's the 2 bytes, then 2 bytes holds the number 26,708. And if I interpret that value starting at 0 as 4 bytes, as a 4-byte integer, then it's going to be whatever number that is. What is it? 1.9 billion? Let's see. Yeah, 1.9 billion. So we're just interpreting the memory differently. And if we interpret it as a float 32, which would be a float in Java, or a float 64, which would be a double, then we're getting, some number, some astronomical number actually, because a float is again 32 bits and a double is 64 bits or 8 bytes. So we're taking all these 8 bytes all the way up to here and interpreting that as a double value. And so the data in the file hasn't changed, and it's actually a nice string that we've written out to the file, but it is being interpreted by the computer because on this line we've asked it to interpret that memory as a single byte of data, as an integer. So it tells us it holds the value 84. But if I come over here and I say interpret my data, or my data in my file as a string, then it's going to print it out as a string. And so all we're doing when we're using data types, int, float, byte, double, string, array, etc., is we're telling the computer how to interpret the ones and zeros that are stored in memory. Okay, so that translates into what we're talking about with objects and classes now, because we are talking about, in the weekly announcement, you probably saw that we talk about how we could solve problems with the primitive data types that we already know. And we've been doing that all semester so far. But if we have more complex data that we would like to use in our program to solve our problems, it gets really hard and really tedious if all we have available to us are these primitive data types. And the example given in the announcement is that of a family. I could use an array of strings to represent a family, but that didn't work too well. And if I could somehow combine a family all into one thing, one data type, then I could hold that in memory and tell the computer to interpret it as a family, and it would give me my family data, that interpretation. And so with that, we're going to switch over and start going through the example that I have for you this week that should help you do the homework. But if you have questions on how computers interpret memory, feel free to ask them in the discussion board. I welcome questions like that. I think it's very valuable for you to understand how this machine that we're going to build our careers on actually works. And having that fundamental understanding is super critical to you becoming excellent at what you do, which will ensure your job security for the rest of your career. So let us switch over to our IntelliJ. Okay, so now we have IntelliJ up, and we've got an example. And we'll refer back to our example of interpreting memory as we develop this assignment. But I wanted to walk through. This is actually from chapter 9 of the book. It's the assignment 9.2 in the back of that chapter. It's the stock class. I'll read through the assignment, and then we'll start dissecting it and kind of give you a demonstration of how you should probably do the same thing as you prepare to do the assignment this week, especially 8.1. So we're going to develop a stock class, like a stock in the stock market. So following the example of the circle class in section 9.2, I do recommend you go read that section and see how they develop that class and how they document it, because we're about to do something very similar. Design a class named stock that contains a string data field named symbol for the stock symbol, a string data field named name for the stock's name, a double data field named previous closing price that stores the stock price for the previous day, a double data field named current price that stores the stock price for the current time, a constructor, and we'll talk about what constructors are as we get to it, that creates a stock with the specified symbol and name, a method named getChangePercent that returns the percentage changed from the previous closing price to the current price, draw the UML diagram for the class, then implement the class, and then write a test program that creates a stock object with the stock symbol ORCL, which is Oracle, and the previous closing price of 34.5. Set a new current price to 34.35 and display the price change percentage. So that's a long description. Let's break it down into what they're asking us to do. So we want to actually create a class named stock. So we'll say, I'm just going to take some notes here, class stock, and it's going to have a field named symbol that's going to be a string. So we're going to say field symbol, and it's a string, and we're going to have a field name, and it's also going to be a string. And let's see, a field that's of type double, so we're going to say field previous closing price, and it's going to be a double. And we'll have another field which is named current price, and it's going to be a double. Okay, so then we're going to have a constructor, and it's going to take two parameters, the symbol and the name. All right, that's pretty cool. And then we're going to have a method called getChangePercent. So we'll say method getChangePercent, and it's going to return the percent change from the previous day. So percent is probably going to need to be a double. So we're going to note that this is going to be a double. All right, so that's our class, and then we need a UML diagram, and then we also need a test program, and this will be where our main is. That's going to create a new stock of Oracle Corporation, I think is the name. And closing price is going to be 34.5. Current price is going to be 34.35. And then we're going to calculate and print the percent change. Okay, so that at least gives us a few things that we can look into doing. And we want to go back and we want to do that spiritual creation of our class. And in the past, as we've done assignments where we've done a simple method that calls maybe another method to get something done, we've actually put our creation steps as comments to outline our algorithm. We're gonna take that to another level, and we're gonna do a spiritual creation of our stock class. And one of the ways that is very effective at doing this spiritual creation, or what in the workplace we call design, one of the best ways of designing code is using UML, and UML stands for Unified Modeling Language, and it is a specification that is way overdone. As a professional developer, I only ever use a fraction of it, and I will show you the most important parts of it in the next couple of weeks as we go through these assignments. Just know that UML is a huge thing. It takes people a long time to learn it, and most professional developers never learn all of it. We just learn enough of it to be able to convey our ideas to our coworkers so that we're all on the same page as it comes to our designs. So I'm going to, just for the sake of convenience, I'm going to copy this text right here. And I'm going to go into draw.io. Draw.io is a diagramming tool that's free on the web. It's a web application, but you can also download a desktop version of it. And I've done that. And that has tools that make drawing UML diagrams extremely easy. So I'm going to demonstrate opening draw.io and using it to create our simple class diagram for our stock class. So we'll stop sharing IntelliJ and we'll start sharing draw.io. Here we go. So I'm going to create a new diagram. And if you're going to be using draw.io, you are welcome to follow along here. I'll give you my tips for using it effectively. There are templates for UML, but I tend to avoid those because they come with all sorts of junk in the template that I end up having to spend a lot of time deleting. And so I'd rather just start with a blank diagram. So we're going to say this is going to be our stock. And I forget how it was titled. So let's hit cancel again and create new. Oh, it's got a .draw.io at the bottom or at the end of it. So we'll call it stock.draw.io. We're going to choose a blank diagram and hit create. And now we get our drawing palette here. And it's a drawing program. So you've got all sorts of options to tweak it, set colors, and I'm going to encourage you to not worry about the colors, not worry about the fonts, not worry about anything but making sure your information is there. And I will say that for this week's assignment, I am totally fine with you drawing out your UML by hand on a piece of paper and taking a picture of it and submitting that with your assignment. It needs to be in your zip file, not secondary to your zip file. It needs to be in your zip file when you submit. You should only submit one file to me, and that should be your zip file with everything in it. But we're going to come down to our UML section that has UML objects in it. And as you can see, there are a gazillion UML symbols that we can use. Maybe not a gazillion, that was a little bit of an exaggeration, but not really too far off. What we're interested in is the class diagram. And so if you hover over the different elements, they'll give you a little pop-up that shows you in something more readable what it is. So we want this class diagram. In UML, a class diagram typically has three sections. The top section is the name of the class, and then the fields or the data is defined after that, and then the methods are defined after that. So we're going to grab a class object, and we're going to expand it because I know we're going to need some expansion here. It looks like we can only expand when we have something to expand it with, so we'll just start typing. So actually we're going to set our class name to be stock. Oh, and I was going to paste something in here, so I'm just going to grab a, do I have a note of anything? I have some text here. This is just going to be my helper because it's going to remind me of the stuff I already printed out, right, that we copied from our, let's see, did we move it down? How many copies of this do I have? We'll move it down, and now we're going to, I'm going to do one thing just to make it a little more readable. I want it to be left justified like it was in my file. There we go. So I'm just using this as a note. This is not something that you would necessarily have in your diagram, but we've already taken the notes, and so it's going to help us. So the class name goes on the very top cell, and then the next one, we're going to start enumerating our four fields. And the way in UML that you do this is your fields are, we have public or private. Public has a plus in it. Private has a minus in it. There's also a type that's protected that you would use a hashtag for it. We're actually going to, and then we're going to declare everything private. I'm going to start you off on the right foot as far as how classes are defined in Java, typical process. So we declare our fields as private, and then we have public methods that get and set those values. So we have here our field symbol, and the format is the visibility is the first symbol, which is a plus or a minus or a hashtag, and then the name of the field, and then a colon, and then its data type. So it's not like Java where the data type comes first. It's like UML where the data type comes afterwards. So we're just going to change it. So we're going to say private symbol string. And next up will be another private name, and it's also a string. And I'm just typing here. This will make sense in a second. Draw.io is like this. It's going to have you overwriting stuff, and then you can adjust sizes when you're ready. We've got a previous closing price. It's also private. And it's a double. And then we've got current price. And it's a double. So that takes care of those. And now we will expand our section so that it allows us to see our data. And then I'm going to give you a little tip here in just a second about the methods. But first, let's take care of the constructor and then the change percent. So Constructors are special. They're not really, I guess they're methods. I won't try to dissect that too much. It's a method that does not have a return type, and it has the exact same name as the class, and that's what makes it a constructor, and that you have to follow that rule because that's how Java expects it. And you can pass parameters into it, and you would use those parameters to help initialize the data in your class when you're allocating the memory for it. So the constructor is called right after allocating the memory, and it gives you a chance to run some code to set up anything you need to set up in your program, in your object as your program is running it. And so we've been told to define a constructor that takes in the symbol and the name of the stock. So our methods should be public so that we can call them, and your constructor should be public if you want people to be able to create new objects of your class. So we're going to say plus, and we're going to call it stocks because it's the same name as the class. And then just like a method signature, we're going to have parentheses, and then we're going to say it takes the symbol, which is a string, comma, and then it takes the name, which is also a string. And that's how we indicate the method there. So that's the constructor. And again, the constructor is called right after we say new stock or new whatever our class is. The computer is going to allocate the memory for it and then call our constructor and have our constructor set up whatever values in our object's memory that we want to set up. And we'll see how this works when we get to actually doing it in the Java code. All right, and then the next thing is we need to have a method called get change percent that returns a double. So we're going to make this public. We're going to call get change percent, and it doesn't take any arguments because it's going to work on the current price and the previous closing price. And that's going to return a double. Okay, so there's our methods. I'm going to make this a little bit longer because these are the methods that we've been told to have. But because we've declared all of our data private, and that's the way the Java developer community has decided is the best way to develop these, I happen to agree. It's a good way to develop your code. If your programming language doesn't support data hiding automatically, like some other languages do, such as C#, then in Java, we have to implement the data hiding ourselves. And data hiding is a good thing. It's encapsulating. We're encapsulating our data into a class, and we are protecting it so that it only gets updated according to the rules that we establish. But so if we have private things in our data, we need to actually have public methods that will help us get and set that data. So I'm going to try to get my text, there we go. So then for our symbol, we would need to have a public get symbol that returns a string. And we would also have a public set symbol that takes a new symbol name, which is a string. And the setter would be void. The getter would return a string. The setter wouldn't return anything because it's going to just update a new value. And then we would do this for each of these fields. Now, I'm not going to go all the way and do this in the interest of time. And I will tell you that there are some purists about UML who think, yeah, you better be writing all this stuff out. And to me, I just want to get the ideas down on paper so that I can communicate them to myself later and to my teammates. And I don't want to waste a lot of time in a lot of the ceremony. So we have developed, a lot of us, and if you show this to a programmer, they're going to understand what you're doing. But the purists are going to say, that's not really UML. And I say, yeah, you're right. And like I said before, UML is way over-engineered, and for what professional developers use it for on a daily basis, we're just going to use the basics. And I'm going to show you a shorthand that is not standard UML, but it's what we use in my line of work to convey that our symbol is going to have both a getter and a setter. So to do that, I will actually put my cursor back up here, and right after my symbol, I'm just going to put in some curly braces, get and set. And to be clean, I'll probably put a comma in there. And my name is going to have a get and a set, and a get and a set, and a get and a set. Now, again, the get and set part of this, it's actually very common in a lot of newer programming languages. C# has a get set thing built into the language. Swift does as well, and Kotlin does as well. That are some of the more modern day languages. And so even Python does, honestly, in kind of a technical way. But this is not standard UML, but I will accept this if you turn it in because it's smart UML. I'll tell you that. So instead of having a get symbol, set symbol, and it's all just boilerplate, it's all exactly the same, I'll just have a quick notation that tells you I intend to have a getter and setter for each of these private fields. So then my UML diagram is much smaller, but let's not drag the text out of there. Let's just get rid of these getters and setters because we already know they're there because we told ourselves up here. So that is actually our class, our stock class. So that's pretty cool. So for your assignment this week, you'll have a rectangle class that does something very similar. It won't be this exact thing, but it'll be something very similar. We can get rid of our note here. So that takes care of that. Not sure where that arrow came from. And now let me demonstrate how to export your file because I don't want, if you're using draw.io, that's fine. I just don't want you, oh, looks like I have to save it here real quick. Let's do that. And projects, week 8. And we're going to save it in the root of our project, not in our source directory. Yeah, the reason is, if you're not using draw.io and you're using something else, I may not have the software, and I'm pretty sure I won't have the software to open it and see your diagram. And so what I want you to do is export your UML diagram. So if you drew it on paper and you take a picture of it, I want to see the picture. You need to put the image file into your source directory so that it gets zipped up and you submit it with your assignment. If you use draw.io or a similar tool, then I want you to export your diagram. So to do that in draw.io, I will go to File and go to Export, and I can export it as a PNG, a JPEG, a scaled vector graphics or SVG, which I happen to love that format, or PDF, which is similar to SVG, but PDF, we all know what a PDF is. And I actually prefer to see the PDF here, but if not, then any of these other 3 formats will work. So let me just demonstrate opening each of the, or exporting each of these. So PDF, we're going to say selection only in this case, because I only want the one diagram, the one class diagram that I had selected. If I had a bigger diagram with relationships between multiple classes, I would definitely select the whole thing. But I'm just going to export, and we're going to put this in our source folder because I want the PDF to actually get uploaded. And then just for demonstration, I'm going to export one more, and we're going to do, let's do a PNG. And I think this is cool. You can actually embed a copy of the diagram in the PNG file. Very cool. All right, so that's actually a demonstration of draw.io. You do not have to use this software. You can use any other software to draw the picture, or you can draw it by hand and take a picture of it. What's important is what's in the diagram. And then just as a reminder, this is my own notation of getters and setters because I get really sick and tired of typing all that text. In Java, if it has one thing I can criticize about it, there's a few things I'll criticize, but this is the biggest one, is it makes you type all this stuff and it gets really old really fast. So that's that. So that's draw.io, and now we're ready to switch over and start coding up our class because we've done our spiritual creation or our design of our class. And with this design, we can then take this and lay down the Java code for it very quickly. In fact, there are some UML programs that are specifically UML programs and not general drawing that will take your diagram and actually write the Java code for you. I actually don't like using those because it doesn't really generate the nicest looking code, but there are tools that do that, and some companies use those. I prefer not to. So let's go back to our IntelliJ. And let's take a look in our source folder. Let's refresh. Can I refresh my project here? I forgot how to refresh. Somebody help me. I'm going to pause here just a second. Okay, I found it. It's right under my nose. It's this reload from disk. There we go. Now our source folder has our two diagrams in it. Two different copies of the same diagram. You only need to submit one. IntelliJ is nice because it'll show you the PNG file right here, and you can see this is exactly what we drew. Got our stock class with the symbol, name, previous closing price, current price, our constructor, which has the same name as the class, and another method called getChange% that returns a double. Good to go. Will it show the PDF file too? Oh, that'll show it in a different program. Okay, so good to go. So please don't submit your draw.io file or any other source file that you use to draw your program. Just export it to a PDF or an image file and stick the PDF or the image file into your source directory. And that way, when you zip up your source directory with your source code in it, then your images will be there too. If you submit your image outside of your zip file, the autograder won't pick it up or include it in your PDF file that I use for feedback. So please try to get those files into the zip file before you submit. Okay, so let's now take this diagram, and I think I want to split my window horizontally. So I'm going to go up to my window or my view, and there's just better ways of doing this than hunting around, huh? All right, never mind. We're just going to come back to this briefly as we go through our code development here. So as I've told you before, I don't work in IntelliJ on a daily basis, but we've chosen it for the class, so I don't want to confuse you with a different tool. But I know I'd find it in a second. I just don't want to waste your time. So we're just going to go ahead and create our next class. We're going to create a Java class, but instead of calling it W8.1 or 8.2, we're going to call this stock. And we're not going to use our CIT 260 class with main template because this class does not have a main method. And this is not intended to be run directly by Java. This is intended to be used by a program written for Java. And so Java has a rule that the class contained in the file has to have the same name as the file. It's actually the other way around. The file has to have the same name as the class. Some people like that, some people don't, but that's the way it is. So our class needs to have a comment on it. And you need to have a comment on your class. If you don't, I'll take a point off. Represents a stock symbol from the stock market. Any comment will do, honestly. I'm just looking for you to develop the habit of writing comments on your code. All right, so our stock will have fields, symbol, which is a string, name, which is a string, previous closing price, and current price. See if I can remember all of that. And we declared them to be private with the minus sign there. So we're going to say private string symbol, and then we're going to say private string name, private double previous closing price, and private double current price. So you're probably, maybe you didn't notice, but maybe some of you did, that I've done something here that we haven't really done before. I've declared them private, but there's no notion of the word static. And we're going to talk about static fields next week. But just know that static means that it belongs to the class itself and not to a variable of the type of class. So the memory for a static field gets stored in memory with the memory for the class. But if we create a new object or a new instance of our class, it will share the static method, the static field, with all other instances of the class. In this particular example, we don't have anything we want to share with all stocks. We have only fields that are pertinent to one stock, so we don't declare them as static. The next thing is we need to have a constructor that takes the name and the symbol. So to create a constructor, we say public. We want to make it public, and we indicated that in our UML with the plus sign there. Public, and there's no return type for a constructor. There's not a void or anything else, and there's not a stock. We just say public stock. That's the name of the class. And then this particular constructor, we've designed that it's going to take the symbol and the name when we create the class. So we're going to pass in a string symbol and a string name. Now, this is something that kind of trips people up, and we'll learn more about it next week as well. But this symbol here is not the same thing as this symbol. This is a parameter passed into a special method called the constructor. And so it becomes a local variable inside of the method here. So to refer to the symbol that's part of my object, I need to specify and tell the Java compiler exactly which variable named symbol I'm after. So to do that, we can say this. This is a special built-in pointer to the memory for each object. And so I'm going to say, I want the symbol that's stored in the memory for my object to get the value of the variable symbol that was passed into my constructor. So this symbol, you can see, hopefully you can see it highlighted there a little bit. This symbol is related to this local variable or parameter passed in. This symbol is actually the one that's pointed to in the memory of our stock object. And the same thing goes for the name. So we'll say this.name equals name. And the reason we do this, I could have given my parameters different names, but to be honest, it takes a lot of brain power to come up with names of things. And you've probably seen me already. I'm just not that creative, and I don't want to spend my brain power on coming up with a creative name when I've got a perfectly good name and I've got a perfectly good way of clearing up any ambiguity that I might have between two things that have the same name. So I don't spend a lot of time coming up with new names of things when the name I have is perfectly fine. So we'll just have a constructor here. We'll say the ticker symbol and the company name. Now, one thing that our example here does not specify that your assignment does is your assignment wants to have a default constructor or a no-arg constructor. So I'm just going to show you how to design this really quick. You'd have a no-arg, so no parameters passed in. And what this would do is it would set up any defaults that you want to have. So I could say symbol equals unknown if I wanted to do that, and name equals unknown. If I wanted my class to have that default behavior, I could do that. So if I created a new stock object with no parameters in the constructor, then it would create a new stock object in memory, and it would automatically set the symbol to unknown and the name to unknown. So we'll call this default no args constructor. This constructor creates a stock object for an unknown company. So some comment there. Okay, and now we've got another method that we need to define called getChange%, and that's going to be, it's going to return a double. So we're going to say public getChange%. It takes no parameters because we've already got everything we need to make the calculation built into our class. And I forgot, in Java, we put our data types at the front. And then we're going to come back shortly and define this method. But first I want to get some other stuff out of the way. So we'll add a comment to this, which is important because all methods in our objects or in our classes need comments. And that's just a standard we have in our class. When you're on your own, you can determine where and when comments are most appropriate. But for the assignment, everything's got to have a comment on it. All right, so getChange%, returns the change percent of the current price relative to the previous day's closing price. Okay, so that takes care of the requirements, other than we've still got a bunch of private data, and we've seen how we could get our symbol and our name into our memory here, but we don't have a way to get our previous closing price and our current price. So we need to produce getters and setters. And these would be our public getters and setters. So we'll say public string get symbol, and we would return symbol. Now, you'll notice I didn't actually have to say this dot up here in the stock constructor, the default constructor, because there's no ambiguity. There's no parameter coming in that has the same name. And everything within a class, if you don't specify this, it will first look and see if there's a variable named that in your class. So the compiler will resolve this symbol just like it did up in the other constructor. It'll resolve it up to this one up here. So it's the same thing down here. I don't actually have to say this dot, and there are some people that think this dot is very clear, and I'm going to say don't do that, please. It just clutters up the code and adds no value. But this, we're going to return the symbol. And then we'll do the setter for it, so we could actually change the symbol name. Public void, because we're not going to return anything, we're going to do something. Set symbol, and now we need to pass in a symbol. So we're going to pass in a string symbol, and I could call it new symbol if I wanted to. That doesn't take too much creative power. And then I could say symbol equals new symbol. Now, if I had changed this, if I had called this symbol, just like in that constructor, you'll see here, I'm probably going to get a IntelliJ idea saying, you're assigning a variable to itself. So in this case, we would then need to have this dot to clarify and get rid of the ambiguity between which symbol is which. But in our case, let's go with the new symbol. All right, so there we go. And we got a lot of typing to do, right? So I'm going to demonstrate something to you. I'm kind of hesitant to do it because I don't want you to get lazy, but I also don't want you to spend forever typing boilerplate code. So we're going to actually delete these two things here, because IntelliJ will generate these things for us. And I think that's a very nice thing that IntelliJ does. Visual Studio Code does it too. All good IDEs will generate getters and setters for your Java classes, because everybody agrees it's lame that we have to do it. But Java doesn't have built-in support for the data hiding, so we have to implement data hiding using methods. But if I right-click here, I can go to Generate, and it's going to ask me, and I've already created my constructor, so I don't need that. I just want to generate getters and setters. So then I will select, and in IntelliJ, I will shift-click to select all of the fields from my class, and it's going to generate getters and setters. And you could pick a different template if you wanted, but we're just going to choose the default IntelliJ template, and then we're going to hit OK. And then, wow, look at that. IntelliJ generated getters and setters for us. And they actually use the this dot technique because, again, they don't want to spend time figuring out how to come up with a better name than what's already there. So you'll notice that there are no comments on this. And I could be very terse and say you got to put comments in all your getters and setters, but that would be just mean, and I'm not that mean. And so it's very obvious what's a getter and what's a setter and what they do. And so you don't necessarily have to comment your getters and setters. And you can see that IntelliJ did a really nice job of writing an awful lot of code that is just boilerplate duplicated stuff. And you could have done this using multiple cursors, but there's a better way to do it. You can use that generate code. Generally though, I will counsel you against using code generation features of your IDE until you understand what those features do and you understand the code they generate. Because if you just start letting IntelliJ fix your problems for you, it's going to insert code that you don't understand, and then when it doesn't work, you're not going to know why. All right, so our stock class is done. But now we need to write, if we go back to our example, we need to write a test program that has the main in it. So this is going to be our w8.example class. It's going to have a main method that's going to create a new Oracle stock. It's going to, we're not ready for this yet. We forgot to implement our get change percent. Let's come back and do that really quick. So our change percent is simply the difference between the closing price, the current price today and the closing price yesterday, and then divide it, and that returns a fraction, which would be a percent. So we're simply going to say double difference equals current price minus previous closing price. And then we're going to say double percent equals difference divided by previous closing price. And then we'll return our percent. So this is a little bit more verbose than I like to do. I would often do this. I would simply return here so that I don't have to have another line of code just to return the value. And then some people might also say, let's just do it all at once. We could say, calculate the difference and then divide by the previous closing price. So you are free to develop this calculation when you do your get area method and your get perimeter. You're free to implement that method any way you can. I do caution you to not be too clever with it because clever code is hard to fix code, but you could do it that way. One thing though that is important is if we're just going to divide by previous closing price, what happens if they don't set a previous closing price? And when we initialize this, if we don't give it a value, Java's going to set it to 0. So in this case, we should probably check and make sure that that we're not going to divide by 0, because computers can't divide by 0. They get really upset if you try. So we're going to say if previous closing price is 0, then we are going to simply return a 0% change. In week 11, we'll learn how to throw exceptions, and that's how we would handle this error. But this week, we're just going to return a 0 and say, you can't have a percent change on nothing. And maybe, and I just had this thought come to me, why don't we come down here on the setter for previous closing price? And why don't we just double check that they're not going to give us anything that's 0 or less than 0. You can't have a price less than 0 either. So let's just do this. If previous closing price, this parameter variable, or this local that's coming in, if it's greater than 0, then we'll go ahead and update the previous closing price. Otherwise, we'll just quietly ignore the call. It's not the best way to handle it, but in week 11, we'll show you a better way to handle this situation. And we should probably do the same thing on the current price, because if a stock price goes to 0, the company's dead. So let's just do if current price is greater than 0, then we'll go ahead and set the current price to the new value as well. So there's some defensive coding, and this is an example of the data hiding, right? If we just made our previous closing price public, then some other code could use it and just set it to 0, and we would never know until we tried to divide it. And so by hiding everything and making it private, and then having a public getter and setter, we can actually write code to make sure that whatever we're setting it to is appropriate. So that's the benefit of having getters and setters. Okay, now we're ready to go do our w8.example. So we're gonna come up here, create a new Java class. Well, now we can use our main template because we're actually gonna have a main method. And I have told you that the comment at the beginning of a program is now optional. I think we've done that long enough that you can decide whether you need to have that comment there or not. So I'm going to model that behavior by not having a comment there. But we're going to model our creation of our algorithm here. So we're going to say create stock of Oracle and then we're going to, oops, set previous close at 34.5, I think is what our assignment said. Previous close 34.5, current price 34.35. So a 15-cent difference from yesterday to today. Then we're going to set current price at 34.35. And we're going to calculate, can't spell today, calculate percent change and print it out. Okay. Seems easy enough. Now you're going to say, how on earth how do I call that? And people use the word call. How do I call stock into my main? You're not actually calling stock into your main. You're just going to use the class. And since our stock class actually exists in the same directory as our main example here, it's automatically imported. So we don't have to import our stock. If it were in a different directory or a different package, directories and packages are the same thing in Java, then we would have to import our stock class from the package that it happens to be defined in. But since it's in the same package or / directory of our main method here, then we don't have to import it. So it's automatically imported. So I can actually just say stock equals new stock, and we're going to pass in the string ORCL for the symbol and the name Oracle Corporation for the company name. And what this line of code does is we're declaring a variable of type stock. Now remember, this is a complex data type. Let's go take a quick look. And it's a custom data type. So it's built up using primitives. We've got 2 doubles and 2 strings. So we could have implemented a solution that does this nicely, but try having an array of multiple stocks when all you have is the fields that make up a stock. Do we have 4 different arrays? That would be terrible. Or a multi-dimensional array, that would be even worse, I think. So by defining a custom type that lets us bind together a bunch of primitives into a custom complex type, we get to have one variable that means all of this. That's what classes do for us. So when we say new, anytime you see the new keyword being used in Java and in any programming language for that matter, you're actually allocating memory for that variable. So we're allocating memory, enough memory to hold everything that the stock class says it needs. So it holds strings and it holds doubles. So we'll have enough memory allocated to hold strings and doubles. And then by saying we want to interpret, by using the data type, this is the actual constructor, but it's part of the data type. By giving it a data type, we're actually telling it how to interpret those bytes of memory, because memory is just flat memory and it's just 1s and 0s. But when we say, oh, the data at this spot in memory should be interpreted as a stock, then all of a sudden Java says, oh, then that means you've got a symbol and a name and a closing price and a current price. And so when we call the constructor here, the constructor is actually going to, this is what's happening, after the memory is allocated, then the constructor gets called and it gets the 2 parameters we pass to it out here. These 2 parameters are going to come in as the parameters, and we use it to initialize our, we're going to use it to initialize our variables. So that's pretty cool. If we don't specify a default value for our variables, they will get some natural default value. So for primitive types, it'll be 0. Like double, the default value for a double is 0, and the default value for a string is null, meaning it has no value. So I actually want to, I'm going to set the default price and closing price to 0.01 so we don't accidentally get a previous closing price of, or we don't get a divide by 0 area when we try to use the previous closing price to divide. So if I set a default value here, and in my setter, I never allow a 0 or less to be in there, then I don't actually need to have this if check. I'm going to leave it in there for now just for illustration purposes, but by setting a default value here, I don't need the if check. So now let's talk really quickly about, is that appropriate? Well, if I've got code that correctly handles my corner case that could blow my program up, that's pretty good. That's actually very good. And I don't really necessarily want to have a default value of 1 penny because that might mean something to somebody. So if I just let it be 0, and then I have protective code later down here, then I'm okay having a default value of 0. If the user updates and sets a new value, I'm going to enforce that it has to be a valid value. But by default, we're safe because we protected ourselves. Okay, that's enough of that little sidebar. Let's go back and let's do the next thing. So now we need to use our setter. So we're going to say stock, which is the variable that we declared. So now this stock variable has a pointer to a spot in memory that we're interpreting as a stock variable. And because we're doing that, we know that there's going to be a set previous close price, and we're going to set it to 34.5. And then we're going to do the same thing for the current price, stock.set current price, and that's going to be 34.35. And then finally, we're going to do the percent. We're going to say double percent change equals stock.get change percent. And then we'll just print it out. System.out.println. The difference is %.2f. And then I'm going to use a percent sign. And so to actually have a percent sign in a string format, I have to use a %%. Like we had a %n that means the same thing as a /n new line character. Because percent is a special character in a format string, if we want to actually have the percent symbol in our string, we have to use %%. And I'll just say percent change. Oh, because I use println and not format. And now we're done. So if I run this program, and we'll run it once and then we'll walk through it in the debugger and then we'll be done. We're going to compile. It's going to compile both of our files. And the difference is -0. What happened here? I guess we're going to need a debugger. Ha! All right. So let's step through our code. We're going to start by putting a breakpoint right here on our front line. We're going to just walk through it. And when we get down to this get change percent, then we're going to figure out the get change percent problem that we're having. So now we're going to debug. And let's watch this happen now. I'm going to use the step in, and it's going to step into my stock constructor. You'll see we're stopped here on main. If I step in here, now you'll see that we're in an init function of stock, and that's how IntelliJ shows a constructor in the debugger window there. But we're coming into our stock constructor, and we can see here we've got a symbol oracle and a string named, and then IntelliJ gives us the this. So this points to the current object that we're working on, the memory for the current object. And you'll see that here that symbol is null. And because we haven't actually executed this line yet, but once I execute this, then the symbol becomes oracle, and then I execute the next line that sets the name, and now we've actually set oracle, the symbol and the name to the same values that were passed in. Okay, that works great. And then our constructor is done. So now I have a stock variable, and it's at memory location 775. And it holds my oracle and my oracle corporation. And closing price and current price of zeros. Cool. So next we're going to call set previous closing price. So let's dive into that. And we're going to check, and we're going to say if previous closing price is greater than 0, then we're going to go ahead and set it, which we do. So previous closing price is 34.5, and we execute this line so that in our this pointer we now have the 34.5. So we've copied that value over into our field from the parameter. It's exactly what we expect. And now let's dive into set current price. And we're going to do the same check. If current price is greater than 0, and we're going to set our current price, which is 34.35. So this works out. So now I've got 34.5 and 34.35 as my previous and closing in my stock. And now we're going to do our stock.get change percent. So we're going to dive into this one and let's see what happened. If previous closing price is 0 and IntelliJ is telling me it's 34.5, we're going to return 0. So we're going to skip over that if check and we're going to say current price minus previous closing price. That should be minus 15. Now, this is where it's actually helpful to break your calculation out if you're going to have problems. So that might be something that would, and we might come back and say, what the heck just happened here? So we're going to say current price minus previous closing price, and we've done that calculation, and we get the percent back, and the percent is actually this number. It's minus 0.0043. So we actually got a value back. Now what we printed out was 0, right? Minus 0.00%. And what happened? Well, we're formatting, right? So formatting, just as a reminder, formatting actually will round, and because we're 0.004, we didn't round. So we're gonna go ahead and print this out, and our console says, look, see, there's our 0% because 0%. Now there is a problem that we've gotten here, and I'll explain that in just a second. I did that on purpose, actually. I did that one on purpose. So we'll just finish that, and we're not exactly getting what we expected, and that's because if I'm using the percent, I probably want to convert that number to something that's actually a percent, because if I have the percent sign, that means I'm expecting there to be like a 4% change instead of a 0.4% change instead of a 4/1000th change. So if I'm going to convert this to a percentage that's easy for humans to read, I need to multiply it by 100. And remember how in previous assignments, we've actually divided by 100 to change a percent number into a fraction. We need to change the fraction back to a percent number. So let's run our program again. And we have dropped 0.43% from yesterday to today on our stock. And that's the number that we expected to have. So that is the demonstration I have for you. Of course, when you're done, you're going to, let's go out to our, well, just remember, we're going to go out to our Explorer or our Finder, and we're going to find our source folder, and we're going to zip up what's in our source folder. So I would expect to see in your submission, you're going to have a rectangle class and then a W9 or W8.1 and a W8.2, and then you're going to have an image file, either a PDF or an image file of your rectangle class. And so that's what I want to see in your zip file. I don't want to see more than one file submitted. You should just have your zip with the right classes in it and the right diagrams in it, and everything will work great. So that's it for today. Thanks for bearing with me. It's a little bit longer of a lecture today, but I want to make sure you get what you have. Please remember, classes are nothing more than custom data types built up of our primitive classes. The class actually tells the computer how it wants it to interpret the memory. In fact, not only the class, but any data type, including classes and also primitives, are just a signal to the compiler telling it how we want the computer to interpret the memory at a certain location. So in our case, the memory allocated by this new, we're going to interpret as a stock. And that's it. We've seen how to draw the diagrams in draw.io. You're welcome to use any other tool you want to draw. All I care about is the image file. So it has to be either a PDF file or an image, like a snapshot from your camera, or if you export your diagram from your tool to a diagram. So PDF, PNG, JPEG, GIF, SVG. And that's it. So fantastic. Good luck this week. I'm thinking of you. I'm praying for you. And ask questions and get answers.